Okay, so it's blurry. Okay, so AB is parallel to EC and CD is equal to DE. That's the first thing you must notice on your drawing. So the first question is asking for the gradient of AB. So by now, should be knowing the formula for gradient. And these are all the formulas you know. So for me personally, if you know these formulas, you can answer any question of coordinate geometry and also, yeah, coordinate geometry. So yeah, it's all over here. Is it all here? Yeah, most of it is here. All of it is here except this one here for the obtuse angles. But that you must know. That's the only one you must know. They give you everything right here. So for you to not know them or to use the wrong formula even in the test or the exam, that is entirely on you. Because everything is given right here. And all you must do is put the right formula down and substitute. That's your only job for this geometry questions. Let us see. They ask for the gradient of line AB. The gradient of line AB. So when they speak of gradient and we know that AB is parallel to EC, we must know that the gradient of AB is equal to the gradient of line EC because they are parallel to each other, right? So, so what's happening here? What's happening here? So the gradient of AB, I'm very lucky because I have the coordinates of A and B. So all I must do is substitute into my formula after I put it down. So very important to note, we have a y2 and a y1 and an x2 and a x1. So when you write down these coordinates into the formula, whichever coordinate you choose as your as your as your x1 and your y1, it should correspond here at the bottom. So you can't take A's coordinate A's y as your y1 and now put the x as the x2. That should be your x1, that should be your y1. That should be your x2, that should be your y2. If you mix them up, you will get the wrong answer. This is this is true for all the formulas you have. You have to put them in the right order as you start. The thing you start with, you must keep it the same for that equation only. But okay, then you substitute, you get your gradient, calculate the work. Never try to do this out your head or to simplify this more. Once you substitute into your formula, calculate it immediately. Don't waste time. Don't um, mix things up by mistake. All you do is you substitute and calculate them.
Sir,
Yes.
can you please record that question?
Yeah, it's recording.
Oh, okay, sure.
Yeah. So the next one, the next question is saying we must determine the equation of line CE in the form y equals to mx plus c. So let me rather use my formula sheet. So yes, what did you do? Oh, 1.2. Oh, okay. Let me see. CE. So yeah, look, you will. Did you use? Can you say again what you used? Yeah. Yes. Yes. No, that is okay. That is okay. Yeah, that's okay. Um. Yes. Yeah. The gradient of AB is the gradient of MCE because they are parallel to each other. So it should be working nicely. So someone is sending me something. So so the next thing is, so we have our gradient. It's a half. Then okay, we're gonna start here. So here's our formula. We write down. The first thing you do is you select the correct gradient. Know which gradient you're working with, and we're working with gradient MCE, the gradient of CE. So what you're gonna do is you're gonna substitute any y value or y and x value from the same coordinate that is on the line CE if you're using this formula now. So the only coordinate we have on this line is E. So where the y is, I put -4. Where the x is, I put 6. Then I just substitute it in. Then I simplify it. I multiply this half in. I simplify this to +4. Then I take this 4 over. Take it over here. And then I have half x minus 7. Very simple and straightforward, right? Once you get the formula, you substitute, simplify maybe a little bit, then you get the answer. So the next question is saying to calculate, let us first read the question, not guess the question. Calculate, determine the coordinate of C. Determine the coordinate of C. So firstly, what you should note is that if CD is equal to DE in length, that means that D is the midpoint of line CE, right? And we must also note that the coordinate D, it is on the y-axis. We just don't have the y value. We do have the y value now because coordinate D is on the line CE. And what does this value mean here? What does this value mean? Can you tell me?
That's the y.
That is the y-intercept of line CE. So the y-intercept here is by coordinate D. That means that the y value of coordinate D is -7. Remember, coordinate D is on the y-axis. And if it's on the y-axis, the coordinate of x is 0, right? Because at the origin, it's 0, 0. And it's on the y-axis. Okay. D is the midpoint of E. We have that. That means we can use the midpoint formula. Let me rather use this. So we can use the midpoint formula coordinate of D, right? And we have at least one x value and one y value. The E now, we have E. So we must determine this x value and this y value because these two coordinates together will give me my C value. So all we must do is substitute and manipulate to get my x value and to get my y value. And we do it like this. We start off like that. We have our coordinates. So this is the coordinate of D. This is my x value of my E. This is my y value of my E. Then all I must do is put this with my 0. The x coordinates go together and then the y coordinates, they go together. So then I get them alone. So this is with my 0, with my x coordinate there. -7 is with my y coordinates. I get my x2 alone, get my y2 alone. Then these values is now my coordinates of my C. They have at the bottom. Oh, and I put it wrong down. C is -6, -10. Always put the x value first. Very straightforward, right? Okay. Now you can't use a. So you didn't get, so you couldn't get my answers, right? You couldn't get the same answers. Okay. 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 Cool. Now as long as we're winning, it's okay. If you're all happy, we can go to the next one. If you're already happy, let me know. Next one is this one. So this one, it's quite straightforward. The drawing is straightforward. There's no extra things or anything. First question is saying, determine the length of PR. Leave your answer in third form. So I look at my formula sheet and I look which formula will give me the length. And I see, okay, yeah, it's the one here with the big square root. So all I do is I write down my formula. I write down my formula and I substitute in. So PR is over here. And I say, okay, I'm going to choose this one here is my x2. So I'm going to take this 4 and this 4. This 4 is my x2. This 4 is my x1. This y is my y2. And this y is my y1. All I do is I substitute in. I put it into the calculator because I don't want to hurt my brain. And then they say leave the answer in third form. And then there's a third there. So I leave it as is. And you finished. Very straightforward, right? In this question is 3 marks. There's your 3 marks for free. Didn't even do anything. That's why these questions should be your 3 marks in the test, in the exam. Should be your 3 marks.
I don't know if it's a good question.
Yeah. Yes, you all get the same answer. Yeah. Do you know why you get the same answer? Do you know why you all get the same answer? Well, also because the squared in the brackets, the squared in the brackets will make anything positive that's coming out. Because the length can't be negative, right? You can't have a negative length. That means the line doesn't exist. So, so also if ever you get a negative answer for a length, you know you did something wrong. Because you can't have a negative length. You can't measure something in the negative. No tape measure has a negative side. No ruler has a negative side. So always have a positive answer for a length, for a distance. Okay. Yeah. Even if you travel backwards, you will still travel a length. You can't go backwards in negativity. You can't go negative, yeah. Anyways, the next question. If the gradient of RQ, the gradient of RQ is -2. So RQ, the gradient of RQ is -2. I put it down there just so I have it as a side note. Find the size of the angle PQ, PQR, yeah, RQP. So I must determine this over here. I must get this one, yeah. I must get that one there. So what I did was I got I got this angle here. I got this angle there. And then how I did that was PQ, PQ. Okay, let us start here. Because they gave us RQ as -2, the gradient of RQ as -2, I can get the angle of inclination of this here. So I can get RKO. And how I got RKO was, I say, because I can see that this is the obtuse angle. This angle is bigger than 90 degrees. So what I said was, um, this angle equals to 180 degrees minus second function tan with a gradient of RQ, which is 2, -2. So then, yeah, that's what it looks like. So yes, the gradient is -2, right? But you're not going to put, so whenever you do gradient, you never put the negative gradient in here. So yes, the gradient is -2, but in a calculation, you don't put the -2 inside there. You never do that. Why exactly, I'm not sure, but you don't do that ever. You'll get the wrong answer. So you do this. So we're gonna get now RKO. Okay, you will see now why we do that. So the answer for RKO is 116,565 degrees. Okay, then what did I do? Okay, yes. So what I then did was, because this here is a straight line, what I did was this this over here is a straight line. So 180 degrees minus this answer here will give me 63. 435 degrees. I think I made a mistake in what I did, but okay, let's give it one. So yeah, so I think I skipped this angle of inclination. I think I skipped the question. No one said anything. Yeah, they said determine the size of the angle of inclination of PQ. If MPQ is 4/3, so PQ is 4/3. That's why my mind was confused because I don't know this angle, but they asked this angle. So this angle is very straightforward. Angle of inclination, it's an acute angle. So the formula is exactly the same. So it's theta equals to second function tan gradient, and the gradient was given to us as 4/3. So PQ, the gradient is 4/3. All I do is I look at my formula sheet and I see, oh, over here is the angle of inclination. So all I do is I substitute in, I get 53.13 degrees. So I have that angle, I have that angle and that angle. If you can see what I'm getting at, I'm getting to the interior angles of a triangle. So my next step is to note that this angle is equal to this angle here, and this angle is equal to this angle there. That is the opposite angles. Yeah, that's opposite angles. This angle inside here is 43.13 degrees. Then all I do is I say the interior angles of a triangle equals to 180 degrees. So 180 degrees minus 63,435 minus 53.13 should give me this over there. And there you get my answer. Whether it's the same as the other one, but it's my answer. So yeah, sometimes you must do a bit extra thinking. This is just a bit more of an extra thinking question, a bit tricky question, but yeah, it can be done if you just take your time and look at it. The next one is actually a lot more questions, but it's a good one. It's good practice. That's why I chose it. But if you're all happy, any questions? Okay. Yolanda, yo. Okay. Um, Tumisa, yes, your hand is up. You have a question? Yeah, we'll do it for you and Yolanda only. Ne? Okay. So, annual inclination for line PQ, we got that over here. So to get that, we got 43.13 degrees. So the angle opposite this angle is the same. So this is opposite angles and they're equal to each other. So this is also 43.13 degrees. Then I got the angle of inclination of line PQ, and I got this angle on top here. So I said this theta equals to 180 degrees minus tan, second function tan, with a gradient of RQ, which is given to us as -2. Then I got 116 degrees, 0.565. So this is a straight line, and then I know that the straight line is 180 degrees. So I say 180 degrees minus this 116.565 gives me 63.435 degrees. So to get this angle that I want, um, I say the interior angles of a triangle is 180 degrees. So 180 degrees minus these two angles will give me this angle here, right? So the answer I got for this one is 63.435 degrees. Yeah. So when you do when you do the angle of inclination, you never put a negative in this angle over here. You never put a negative there. If you put a negative there, you'll get a wrong answer. I'm not exactly sure why you don't do that, but you never put a negative there. Yeah, you see, that is way too big. Yeah, that's way too big. That's why, like, it doesn't make sense for it to be that big, also, you know? Like, it's bigger than 90. Yes, it's bigger than 90. 90 would be here somewhere, right? So it wouldn't be that far. 200, yo, that's like it's here somewhere. Like, yeah, it's the side. So it's way out there. It's too out there. Never put a minus on any one you do here. Even no, no, we'll get to trigonometry. We'll get to trigonometry when we get there. But I think it's the same trigonometry. Yeah, you don't put the negative in there. Yeah, you never put the negative for trigonometry either. But we'll get to that. But you never put negative in there, guys. Never do that. You'll get the wrong answer. Okay, let's go. Yeah, let's finish you and I. Yeah. Anyways, um, firstly, we start by looking at our drawing, and our drawing is showing us that line AB is parallel to line CD. Maybe my drawing doesn't look that way, but they are parallel. We have an angle here, beta, and we have an angle there. I think that is, what's his name? That's alpha. Yeah, alpha. So, question one, the length of AB. Now, what do I do with this, please? So, I look at my formula sheet and I look, where is the formula for length and distance? I find it's there. All I do is I substitute in my values for AB. Then in the calculator, I get my answer 10. Straightforward. 3, 2 marks. Question 2. The gradient of the line AB. I should know by now that when lines are parallel to each other, that means they have the same gradient. Lines that are parallel to each other have the same gradient. So they're asking to get the gradient. Yeah. No, I finished it. Yeah, we finished it. What should I do? No, I think we finished it. Yolanda, Dumisa, did we finish it? Okay. No, we did finish it, Mr. Glenville. We did. Okay, okay, no problem. Okay, yeah, so they're saying calculate the gradient of AB. All I do is go to the formula sheet. The formula for gradient is where? Oh, there's no formula for gradient. So you must learn the gradient formula. Oh, I didn't see that. Gradient, so you say m equals y2 minus y1, x2 minus x1. So you must know the gradient formula, guys. Oh, I didn't see that. But okay, we're gonna know it most. So only one you must know actually. And also this one, this one here is for acute angles, and then the angle of inclination for theta equals to 180 degrees. This here is for obtuse angles. Obtuse. Yo, my spelling is going mad now. Obtuse. That is extra ones you must know from the formula sheet. But we're gonna know them. Anyways, I find my formula, or I know my formula, I put it down, I substitute in my coordinates from line AB, and I calculate that thing, and I get 4 over 3. Then already, I put down for my own knowing that gradient of AB and gradient of DC will be the same. So I just put it down for myself here at the bottom. The next question. This should be straightforward, guys, and this is 4 marks for you already. The next question is saying the equation of line CD. Determine the equation of the line CD. Leave your answer in the form of y equals to mx plus c. And then the formula for an equation of a line, we must use that formula over there. Y minus y1 equals to mx minus 1. You start by writing it. Then you see on line CD, what coordinates do I have on the line CD? Any coordinate on line CD will work and do the job. So you see, okay, coordinate D. So you put where y1 is, you put coordinate 8 there. You put the 8 there. For the x1, you put 9. For the gradient of CD, you put 4 over 3 because we know now that the gradient is the same here at the bottom, right? So you can have 4 over 3 x minus 9, and then you're gonna on that side you're gonna have y minus 8, like that over there. All you do now is you multiply this 4 over 3 into the brackets, then you simplify to get it in the form y equals to mx plus c. So this 8 must come over as well at some point, right? Here it comes over, there you simplify, and that's your answer. Very straightforward. Very straightforward. Steps never change. As long as you have a coordinate on the line CD, you can substitute it and then you'll get your answer. The next question is to determine the coordinates of point C. So we had a similar question in the previous question. So we must note that C is on the y-axis. And when it's on the y-axis, we know that, yes, you're breaking up. I couldn't hear you there. Can you repeat yourself, please? Yeah. Yes. Yeah, you can put in the calculator also. Yeah, you see, never break your brain in the calculator quickly, and you get 12. Yeah, yeah, yeah. It's a weird one. Okay, yeah. The next question is saying we must calculate or we must determine the coordinates of C, and we must note that C is on the y-axis, and if any coordinate is on the y-axis, the x coordinate of that will be 0. So all we must determine is the y value for that coordinate. And now we have that y coordinate because we determined the equation of the line CD. So here we have it over here again, the y-intercept. Can we please mute there, Mr. Clyde, if you don't mind? Thank you. So yeah, we have the y-intercept of that line CD, and it's -4. So we have our y value there. So there we have our next 2 marks for free. So that is 8 marks we have. That's actually 5, 6, 7, 8, 9. That's 9 marks already for free. So I just wrote it down like that. 0 and -4. The next question is saying determine the equation of the line in the form of y equals to mx plus c, which is perpendicular to CD, passing through point C. So I hope you guys have the question in front of you. So they're saying determine the equation of the line in the form of y equals to mx plus c, which is perpendicular. So which is perpendicular to line CD. So this is our CD over there. So in this line, they are saying it's perpendicular. It's perpendicular to the line CD. This line they are talking about, ne? This line here they're talking about. It's passing through point C and it's perpendicular to line CD. This question has been asked a lot. So just draw it for yourself also. So determine the equation of this line here. So how do I do that? So how I do that is determine the gradient first. So we know the formula for determining the gradient that's perpendicular to a gradient I already know. So in my formula sheet, I see that there's perpendicular lines. So the gradient of one line multiply the gradient of the second line equal to -1. So all I must do is I put the gradient I do have and I either cross multiply or I manipulate, determine the equation of the line in the form of y equals mx plus c that is perpendicular to line CD. So we have that. We have our CD, and we must determine the equation of this line here. It passes through point DC, that passes through coordinate C, and is perpendicular to line CD. Okay. First thing we must get is the gradient. To get a gradient that is perpendicular to another gradient, we use this formula over here. M1 times M2 equals to -1. So the gradient I do have multiply the gradient I don't have equal to -1. Then all I must do is manipulate to get the gradient I don't have. Cross multiply, divide to get my answer. And I did that over here. I did over here. A shortcut for this, a shortcut for this is I have the gradient of 4/3 for gradient CD. right? I have CD. Um, so to get the gradient as perpendicular to this gradient is I do the reciprocal of that gradient, which is 3 over 4, and I put a negative with it. This is now my new gradient of my new line. So I'm going to put it as M2. And yes, here's the same answer. This is a shortcut. It's the exact same thing, but this is just a quick one. If you know it, it's quick. Then the very same thing is so when I go back. So let's say I had so this gradient M2 is now this gradient over here, right? So if I had this gradient and I did not have the gradient of CD, to get my gradient CD, I would have to do the reciprocal of this, which is 4 over 3, and I multiply this, or I multiply the negative. Or if it had a negative, I must take away the negative now in the next one. So I do the reciprocal of this, which is 4 over 3, and I remove the negative. If there was no negative here, I will do the reciprocal and multiply with negative to get that gradient. Hopefully I'm making sense there. If you see your hand is up,
Yes, good day, sir. Your screen is listed.
I can see clearly now the rain has gone. Beauty. I don't know, you wash your screen. Wash your screen. I don't know, maybe you put your internet on and off again, join us again, rejoin us. I don't know what you can do. Guys, does the gradient make sense? Either you can do the shortcut or you can do the other one from the cross multiplying or dividing one time. Then in the calculator, I try to think much. I don't want to think much. I just put in the calculator, I get my answer, and then I pay. You can choose either one. Yeah, then all is well. Yeah, I can do that. Not a problem. Okay, so I have my gradient now. I got my gradient of my line. So my next step to do is to put the formula down for the equation of a line. So I'm going to have y minus y1 equals to m for gradient x minus x1. I'm going to have it there. So I must put the gradient of the line I'm working with, which is this line here, passing through coordinate C, perpendicular to line CD. That gradient's name is M2. So I'm going to have, remember now, for an equation of a line, I need at least one coordinate that is on that line to make the equation of that line. And the only coordinate on that line is coordinate C once again. And I have that coordinate, which is lovely for me. So what I'm going to have is y minus negative 4 equals to negative 3 over 4 in brackets x minus 0. And there I have it over there. Then I simplify, I say y plus 4 equals to negative 3x plus a 0. Just because. Just because I know I'm going to bring this 4 over, right? Because it's an equation of a line. And they have it like that. Take the 4 over, and I'm left with y equals to negative 3 over 4x minus 4. And that's my answer. All you must do, very important, know which gradient you are working with. Keep that gradient with your equation. The next question is saying, if everybody's happy there, determine the coordinates of point P of point P. Determine the coordinates of point P. So I have, okay, so we must note that point P is on the x-axis, and I know that when a coordinate is on the y-axis, the x value is 0. So when a coordinate is on the x-axis, the y value is 0. So the only one I don't know is the x value, right? I don't know the x value now for P, but I know the y value because it's on the x-axis. So I know the gradient of line CD. So I'm going to use the gradient formula and manipulate it to get me my x. So I'm going to use these two coordinates to substitute them on my gradient formula, because as long as the coordinates of my line, or as long as the coordinates that I'm going to use is on the line with the same gradient, the gradient will be the same. The gradient here is the same as the gradient there, with the same as the gradient here, right? So I can use any coordinate here. I can use C and D to get the same gradient. If I use D and P and C, I'll get the exact same gradient. So I'm going to use coordinate P and coordinate D to get my x coordinate there. So all that is this. I first write down my formula for gradient. I write it down, and then I substitute in my values. I put in my gradient value, which was, I think, yeah, 4/3. So 4/3 equals to, I don't know which one I guess is my y2. Yeah, 0. Okay. So I put my 0 as my y2. My y1 is 8. So 0 minus 8 over x2 minus 9. So I'm going to have 4/3 equals to 0 minus 8 over x2 minus 9. Like that. And all I must do is cross multiply and solve for x basically. Cross multiply there. I multiply in the brackets, and then I get that, and then I get 36 over. I divide with 4, and my x2 value is 3. So the x coordinate for my P is 3 and 0. 3 and 0. So very important. Or not, yeah, let's say this. Very important. So I could have used point C to get the exact same answer, but I didn't use point C because I may have made a mistake. I don't know. So at all times, use the given coordinates where you can, as much as possible, use the given coordinates. Because maybe you make a mistake. Maybe you make a mistake to get the C coordinate and it's wrong. Now you use this wrong answer in the equation here. So this is also wrong. Where you could have used the given equation and get a mark somewhere. That's just an extra something you must know and do. Okay. So next question is saying, okay, is everybody happy with this? Is everybody happy the way I got the P value, the P coordinate? Who is not happy? Speak now, ever hold your peace. Okay, if we're happy there. The next question is, determine the size of angle beta. This one here. of the angle of inclination between line CD and the x-axis. So they want this one here. So we must see that beta is an acute angle. So acute angle means um, it's going to be this one here, all right? This one here. So all I do is I write it down, and I must always know which gradient I'm working with. Very important. It's gradient that's 4/3. I substitute in, I put in the calculator, and whoops, my uncle, that's the answer, 53.13 degrees. Straightforward, right? You should know that by now. The last question is saying, determine the size of the angle of OCP, which is this alpha over here. Determine this alpha here. So, in the previous question, we had a similar question where it said that, okay, we had the angle here and we had the opposite angle here. So, I must know that this angle beta here is equal to this angle there. So, that's also beta. So, that's also 53.13 degrees. This I know is a 90 degrees because it's a Cartesian plane. It's a Cartesian plane, so it's 90. My y and my x-axis make a 90 degrees over there. All I do is I use the interior angles of a triangle. Interior angles of a triangle. 180 degrees minus the 90 minus 53.13 degrees will give me my alpha over there, which is 126.87 degrees. And that's my question. This can be your 3 marks, guys. Can really be your 3 marks. I don't have any questions. Is everybody okay with this? Do you feel confident enough in the geometry questions? I don't think it's necessary to go through algebraic ones because I had a lot of examples in the previous video. Are we ready for trigonometry? Yes, of course. 100%. 100%. And and you guys have more than enough in the group that I sent you. The PDF, I will send it again. There's more than enough questions in there, guys. More than enough to practice for the whole exam. So you have more than enough. You can do that, yeah, or you can do some hunting in the in the past question papers to see the memo. But you can send to me also, it's fine. Yeah. Also, guys, help each other where you can. If you know something, say something. Yeah. Uh-uh. OCP is this over here. Is this angle over here. Oh, I think mine is wrong, yeah. Yeah, mine is wrong. I think I put in a calculator wrong. Yeah, A36, 100% nice. Nice, yes, that's correct. Yeah, now that's it, guys. There you have it. You see, you must just calculate that thing nicely. If you calculate it wrong, yeah, you get the wrong answer. Yeah, I was in a hurry. Um, but everybody's happy. Then we can call it a night, and then we can do trigonometry from now until next week.